Good morning, everyone. Today we are going to introduce the last method to prove the two triangles congruent, which is called HL. So let's start the lesson. Again, in this lesson, we are going to have two videos. The first one, we are going to introduce a method, and the second one, we are going to practice several examples to reinforce our understanding for this method. So let's get started. So the first one, we are going to have a quick warm-up. Please check these two triangles carefully. Do you think we have enough information to prove these two triangles? If so, what's a method will you choose? You can definitely pause the video here to check the result, and then you can compare the answer with my answers later. So let's check what are the information we have here. If you check the marks here, we have angle V is congruent to angle H. That's a single curve mark we have here. And we also have angle U is congruent to angle G. And we also have VT, size VT is congruent to size FH. Again, it really doesn't matter how do you write the, you can write HF, you can write FH, it's the same thing. Now, let's check the position of this. So we have, as we learned before, we have SSS, SAS, AAS, and ASA. That's all the methods we have so far, right? So if you check carefully, you have one pair of angle. We have another pair of angle. We also have the side, which is not in between the two angles here. So that's why this two triangle actually congruent by, this is the method we are going to choose. So one pair of angle, another pair of angle, and also the side. So some student might argue, why not ASA again? In order to be ASA, the side has to be between the two angles here, which should be this one, which is not this case, so that's why it should be AAS. Now let's write down the final congruent statement. So triangle UVT, again, the first triangle can be any order, but the second one has to match whatever the order you created here. So angle U is matching to G, and also V is matching to H. Then the last one is just T to F. Okay, so it's GHF by, do not forget to indicate the method, which is angle, side. Okay, so that's a first warm-up. But before we start the lesson, we are going to have a quick prior knowledge check. What does that mean? So we are going to look at this triangle here. Some students already noticed that since we have a little corner in this one, so this indicates this is 90 degrees, so this is going to be a right triangle. So question for you is, what do you remember about the three sides of a right triangle? Some student might, you can definitely pause the video and think about this question here. If you do not remember, that's perfectly fine. That's why we have a quick checkup. So we all know for three sides is a squared plus b squared equal to, equal to c squared, which is called Pythagorean theorem. We also, so these two, excuse me, so these two sides we indicate as A, B. So some student might say, can I indicate this one as A, this one as B? That's perfectly fine. But this one, the longest side, we always call C. And let's just quickly try to recall the name for each side. So we call these two sides, the two sides form a right angle, we call leg. And this one we call, the longest one we always call hypotenuse. Hypotenuse is always the longest one, and we call these two sides our legs. Okay, so that's a quick review. That's a quick review for the right triangle. So some students might wonder, why do you mention right triangle here? That's actually related to our last method here. So last method says if the hypotenuse and the leg of one right triangle are congruent to the corresponding parts of another one, meaning one hypotenuse congruent to the other hypotenuse, one leg congruent to the other leg, congruent to the leg of another triangle, then these triangles are congruent. And as you can see, the key word here, we actually talking about the right triangle. Since we're talking about the hypotenuse and the leg, so that's why this method called HL. So let's write down this congruent statement for complete this if-then statements. So if, again, we are talking about the right triangle here, so angle B is congruent to angle D, which is 90 degree. That indicates this is a right triangle, and we also have hypotenuse congruent to hypotenuse, the longest one, and leg, one of the leg AB is congruent to the one of the leg of the other triangle ED. Then these two triangles are congruent. So ABC congruent to, again, please make sure it matches. So A is matching to E, B is matching to D, then C is matching to F by HL. So several things I want to remind you. We are talking about one pair of hypotenuse and one pair of legs. They're congruent. And also this method is only working for a right triangle. However, that doesn't mean if I give you a pair of a right triangle, you can only use this way. So I just want to remind you that. Doesn't mean you can, so if I give you a random right triangle here, doesn't mean you can always use HL. It really depends on why the information, how the information is given. And also another thing I want to remind you, how does that work? So as we know, three sides of the right triangle has a squared plus b squared equal to c squared. I'm going to write again. If I know this side and I know this side, according to this equation, I know hypotenuse, I know leg, then I definitely know the third one. So the third one we will know. Even we do not solve it, we can find the answer. Since so that means I have two sides, I already know the third one, so that's actually coming to the SSS. Because we know the first two, we already know the third one. So for a right triangle, all I need is two sides. Then I will know this. I will know the third one. So that's why HL is enough for us to prove the two right triangles congruent. That's why we can have the fifth method. However, one more thing though, just want to remind you again, even this is only working for right triangle, but doesn't mean when we have right triangle, that's the only method we can use. We can still use all different methods. It's really up to the given information. Okay, that's the first part. The second video, we are going to look at the several different examples to reinforce your understanding for HL.